for the situation. Let's talk about what we're dealing with. Suppose an archaeologist discovers 7 fossil skeletons from a previously unknown species of miniature horse. Reconstruction of the skeleton of these 7 miniature horses show their shoulder heights to be. Okay, so on here, I've got one sample here. For the sample data, the sample mean is 46.14 and the sample standard deviation is 1.19. Let mu be the mean shoulder height in centimeters for the entire species of a miniature horse. Assume the population is approximately normal. Find the confidence interval. So first off, they do tell us it's approximately normal. So it's approximately normal. Okay. Now the key is on this one, we do not know the population standard deviation. We know the standard deviation, the sample standard deviation, but not the population standard deviation. So sigma, the population standard deviation, is unknown. So when this is unknown, what you're going to have to do is you're going to have to use the t distribution. Okay, you're going to have to do a t interval. Okay, do a t interval. First thing we want to do is we're going to construct the margin of error. Margin of error is equal to the critical value of t times the standard deviation divided by the square root of n. Now, what is the critical value of t? Okay, let's think about this. I forgot to put this, 99% confidence interval. That's important. Okay, so if I do a 99% confidence interval, I'm going to kind of do what I did on the last page. That means 99% is there, 0.5, 0.5. I'm going to do inverse t, 0.995. And then my degrees of freedom is n minus 1. So I've got 7 in my sample. So 7 in my sample, 7 minus 1 is 6. Okay? So my t is 3.707. That's my critical value. Standard deviation is 1.19. Divided by the square root of n. My n is 7. So 3.707 times 1.19 divided by the square 667. So that's my margin of error. Now I'm going to construct the interval. So how do I construct the interval? It's the sample mean minus the error is less than mu, which is less than the sample mean plus the error. So I'm going to take my sample mean, which is 46.14, subtract the error, and I'm going to do my sample mean 46.14 and add the error. This is going to give me my lower bound and my upper bound. Okay? So 46.14 minus 1.667, 46.14 plus 1.667. So 44.473, 47.807. So that's my lower bound. This is my upper bound. Okay? Now, I could also do this in the calculator. Okay? I can go to stats, test, t interval. So I can also do this in my calculator, which is probably a lot easier. Stat, test, t interval. I'm going to use stats. Now, I could enter this into a list and do a data, but I'm going to do stats. Whoops, stats. My x bar is going to be my sample mean, which is 46.14. My s of x will be my sample standard deviation, which is 1.19. My n equals 7 because I have 7 in my sample size, and my c level is 0.99 because it's a 99% confidence interval. So again, I mistakenly did not provide that for you. Calculate, and so you get the same thing here, 44.472, 47.808. Okay, a little off because of rounding. We rounded a little bit here. That's why I was a little off. Now, how can we interpret this? Well, here's one way to interpret it. What we could say is the archaeologist, make sure I spell that right, A-E-O-logist, can be 99% confident that the interval 44.473 to centimeters to 47.807 centimeters contains the population mean mu of shoulder heights for this species of miniature horse. Okay, so we're using the t interval instead of the z because we do not know the population standard deviation. And so on your SALT, you're going to use one sample t on your SALT and inversion statistics.